Welcome to the video on probability. We'll just start with the definition of probability. The probability of an event is just the likelihood of that event occurring. And it's possible to calculate the probabilities of events that occur randomly or by chance using a certain formula. And that formula is x divided by n. That's the formula that's used to find the probability of an event. And let's talk about what x and n stand for. X is the number of possible ways that an event could occur, and n is just the total number of possible outcomes that could happen. And I think this formula will make more sense once we go through some examples of using the formula. But before we go through examples, I wanted to talk a little bit more about the theory behind probability. So the probability of an event is always a decimal between 0 and 1. An event with a probability of 0 never happens, and an event with a probability of 1 always happens. So this is the lowest probability that's possible, and this is the highest probability that's possible. And basically, the higher the probability of an event, the more likely that event is to happen. So if an event has a probability of 0, it never happens or it can't happen, and an event with a probability of 1 will definitely happen. It always happens. And the further a probability is above 0, and the closer it is to 1, the more likely the event is to happen. For example, an event that has a probability of 0.7 is more likely to happen than an event that only has a probability of 0.4. Also, if you take the probability of an event and you multiply it by 100, you find the percentage of the time that that event will occur. Let's look at some examples. An event with a probability of 0 happens 0% of the time, because if you multiply 0 by 100, you get 0. An event with a probability of 0.35 happens 35% of the time, because if you take 0.35 and multiply by 100, you get 35. 0.35 times 100 equals 35. 0.70 times 100 equals 70. So an event with a probability of 0.70 happens 70% of the time. And 1 times 100 equals 100. So an event with a probability of 1 happens 100% of the time. This makes sense because I told you that an event with a probability of 1 always happens. I also told you that an event with a probability of 0 never happens. So it makes sense that an event with a probability of 0 happens 0% of the time. We can also see that events with higher probabilities happen more often, because we can see here that as these probabilities are going up, these percentages are going up also. Now let's go through some examples of finding probabilities. So if we flip a coin, what's the probability of getting ahead? In order to answer this question, we have to use that formula that I showed you, which is x over n. X is the number of ways that the event could happen, and n is the total number of possible outcomes. So if we flip a coin, there's 2 possible outcomes that could happen, because there are 2 sides to the coin, which means that the bottom of the fraction will be 0. There's 2 outcomes that are possible. There's also, and out of those 2 possible outcomes, only one of them leads to a head, because only one side of the coin has a head on it, which means that the top of the fraction will be a 1. So there's so out of 2 possible outcomes, only one of them leads to a head, which means that we're going to have a 1 on the top and a 2 on the bottom. So the probability of a head is 1/2. And if we, so that's pretty much our answer. And if we divide 1 by 2, if we divide the top of the fraction by the bottom of the fraction, we can change our answer to a decimal. So another way to write the answer is 0.5. You can either leave the answer as a decimal, or you can multiply the top by the bottom and get a decimal answer. Now, what's the probability of a tail when you flip a coin? Well, we can use the same formula we did before, x over n. The bottom of the fraction, which is n, is the total number of possible outcomes. And like I said, when you flip a coin, there's two possible outcomes. You'll either get one side or the other. And out of those two possible outcomes, only one of them leads to a tail, because only one side has a tail on it. So the top of the fraction is 1. The top is 1 and the bottom is 2, which means that the answer is 1/2. Or if you divide 1 by 2, if you divide the top by the bottom, you get a decimal answer of 0.5. Another way to think about this is, when you flip a coin, 1 out of 2 outcomes lead to a tail, which is why the answer is 1 over 2. So when you see this 1/2 right here, you could also think of it as 1 out of 2 outcomes. Now let's look at this table right here. This is just showing the two possible outcomes and the probability of each event, both as a fraction and a decimal. So these are the answers that we just found together. Let's now, before we move on, we could also multiply each decimal probability by 100 and get the percentage of the time that the event will happen. So 0.5 or 0.50 times 100 is 50. And this other probability of a tail, which is 0.5 times 100, also equals 50. So when you flip a coin, heads happens 50% of the time, and tails happens 50% of the time. Now, these are the percentages that happen over the long run, meaning if a coin is flipped over and over and over again a very large number of times, these are the percentages that happen over the long run. If you flip a coin just a small number of times, like let's say 10 times, you're not necessarily going to get these percentages. If you flip a coin 10 times, you're not necessarily going to get 5 heads and 5 tails. But these are the percentages that happen over the long run. Actually, what happens is if you flip a coin over and over again, and you keep track of the percentages, these percentages keep getting closer and closer to 50 and 50. So actually, the more times you flip the coin, the closer and closer the percentages will get to these two percentages right here. Here's another example. If a card is drawn from a shuffled deck, what is the probability of a red card? Well, we have to use that x over n formula again. Remember, x, which is the top of the fraction, is the number of ways that the event could happen. So we have 52 cards in the deck, and 26 of them are red. So there's 26 ways to get a red card. So the top is 26. The bottom of the fraction is the total number of possible outcomes. If you take a card from a deck, each card in the deck is a possible outcome. So since there's 52 cards in the deck, there are 52 possible outcomes that could happen. So we have 26 over 52. 26 out of the 52 possible outcomes lead to a red card, so that's our answer. You could also reduce the fraction if you wanted to. This reduces to 1/2, and then you could also divide the top by the bottom. 1 divided by 2 equals 0.5, and that would be the answer as a decimal. This is the notation that's used for probabilities. So if you look in a statistics textbook, you'll see it written out this way, where the probability of an event is written as P and then the name of the event inside the parentheses. So if they're finding the probability of heads, it would be P heads, or if they're finding the probability of drawing an ace, it would be P ace. I just wanted to explain what this notation is right here. What about the probability of a black card? Well, there's 26 black cards out of 52 total cards, so the answer is 26 over 52, which reduces to 1/2, and then 1 divided by 2 is 0.5. That's our answer. So actually, red and black each have a probability of 1/2, just like how heads and tails both had a probability of 1/2. And if you multiply the probabilities by 100, this equals 50, and this equals 50. So just like how heads happens 50% of the time and tails happens 50% of the time, if you keep drawing a card over and over again from a shuffled deck, red happens 50% of the time, and black happens 50% of the time over the long run. Now here's another example. If a card is drawn from a deck, a shuffled deck, what's the probability of a diamond? Well, there are, I believe, 13 diamonds out of 52 cards, which means that the answer is 13 over 52, which reduces to 1/4. And if you divide 1 by 4, you get an answer of 0.25. Notice how in each of the examples I'm saying a shuffled deck. If you want to find the probability of a card, the deck has to be shuffled because, like I said earlier, you can only find the probability of a random event. And when you draw a card from a deck, the card that you get is only random if the deck is shuffled. Obviously, if I stack the deck the way I want to, the card that I get isn't random. Also, what's the probability of a heart? Well, 13 out of 52 cards are hearts, so it's the same answer. Actually, every suit in the deck has 13 cards. There's 13 hearts, 13 diamonds, 13 clubs, and 13 spades. So each of the 4 suits has a probability of 13 over 52, or 1/4 if you reduce. So a spade is also going to be the same answer. And here's the table that shows all of our answers. And now let's multiply each probability by 100 to find out the percentage of the time that suit will be drawn. Well, these all come out to 25, so over the long run, each suit will appear 25% of the time if you're drawing from a shuffled deck. I also have some examples of some dice probabilities. If you roll a piece of dice, the probability of a 1 is 1 over 6, because there's 6 sides to the piece of dice, and 1 out of 6 sides show a 1. So the answer is 1 over 6. Or if you divide 1 by 6, this is the decimal answer. Well, also 1 out of 6 sides have a 2, so the answer is still 1 over 6. Actually, there are 6 sides, and each of these numbers only appears on one of the sides. So each of these numbers has a probability of 1 over 6. And if you want to find the decimal answers, just divide 1 by 6, and you get this number right here. And just like before, we can find the percentage of the time that each event happens. So if you keep rolling a piece of dice over and over again, over the long run, each number will appear 16.7% of the time. Notice how each side appears equally often because they all have the same probability. I'm going to skip over the addition rule. Let's go over the addition rule. In probability, the addition rule says that if two events are mutually exclusive, meaning only one of them can happen at a time, then the probability of event A or event B happening can be found by adding the probabilities of the separate events. Mutually exclusive means that the two events can't happen together. Either one happens or the other one happens. For example, when you flip a coin, heads and tails are mutually exclusive because you're going to get heads or tails. You can't get them both. So this is saying that if two events are mutually exclusive and they can't happen together, the probability of A or B happening is equal to the probability of A plus the probability of B. Here's an extension of the addition rule. If events A, B, and C are all mutually exclusive, meaning only one of them can happen at a time, the probability of A, B, or C happening can be found by adding all three probabilities. So the probability of A, B, or C equals the probability of A plus the probability of B plus the probability of C. And now let's use the addition rule to find the probability of getting a head or a tail. These two events are mutually exclusive because when you flip a coin, you get heads or tails. You get one or the other, and you can't get both. So we can use the addition rule to find the answer to this question. So here's the addition rule right here. It's saying that we have to add the probability of a head and the probability of a tail to get the probability of head or tail. Well, we already figured out together that the probability of head is 1/2 and the probability of tail is 1/2. So the answer is just the total of those two probabilities. 1/2 plus 1/2 equals 1. Well, when you add fractions that have the same denominator, meaning when you add fractions that have the same number on the bottom, you just add the two numbers that are on top. So 1 plus 1 equals 2. Let's go over the addition rule. The addition rule says that if events A and B are mutually exclusive, meaning only one of them can happen at a time, then the probability of event A or event B happening can be found by adding the probabilities of the two events. And I wanted to explain a little bit about what mutually exclusive means. If two events are mutually exclusive, that means that either one event or the other happens. The two events can't happen at the same time. When you flip a coin, heads and tails are mutually exclusive because each time you flip a coin, you either get heads or tails. You either get one or the other, and you can't get both at the same time. Also, each time you draw a card from a deck, red and black are mutually exclusive because each time you draw a card from a deck, you get red or black. You get one or the other, but you can't get both colors at the same time. So this is the addition rule down here. It says that if events A and B are mutually exclusive, you can find the probability of event A or event B happening by adding the probabilities of the two separate events. I wanted to talk a little bit about the addition rule. In probability, the addition rule says that if two events are mutually exclusive, meaning only one of them can happen at a time, then the probability of event A or event B happening can be found by adding the probabilities of the two separate events. Before we move on, I wanted to explain a little bit more about what mutually exclusive means. If two events are mutually exclusive, it means that either one event or the other happens, and they can't happen at the same time. For example, heads and tails are mutually exclusive because each time you flip a coin, you either get heads or tails. You either get one or the other, and you can't get them both at the same time. Also, if you draw a card from the deck, red and black are mutually exclusive because each time you draw a card from the deck, you either get red or black. You either get one or the other, and you can't get both colors at the same time. So here's the addition rule down here in symbols. It says that if events A and B are mutually exclusive, then the probability of event A or event B happening, one or the other, is equal to the total of the probability of event A and the probability of event B. Here's an extension of the addition rule. It says that if events A, B, and C are all mutually exclusive, meaning only one of them can happen at a time, then the probability of event A, event B, or event C happening can be found by adding the probabilities of all three events. So if all three of these events are mutually exclusive, and only one of them can happen at a time, then the probability of A, B, or C happening is equal to the total of the probability of A, the probability of B, and the probability of C. Now that we've gone over the addition rule for both two events and for three events, let's go through some examples of using the addition rule. First, let's use the addition rule to find the probability of getting a head or a tail when a coin is flipped. We said that if you flip a coin, heads and tails are mutually exclusive events because when you flip a coin, you either get a head or a tail. You either get one or the other, and you can't get both a head and a tail. So, since these two events are mutually exclusive, we can use the addition rule to get the answer. So, we know that the probability of a head is 1/2, and we already know that the probability of a tail is 1/2 because 1 out of 2 sides have a head, and 1 out of 2 sides have a tail. That means that the probability of getting a head or a tail when a coin is flipped is equal to the total of these two probabilities. So we just have to add 1/2 plus 1/2 to get the answer. Since the two fractions both have the same denominator, since they both have 2 on the bottom, we can just add the two numerators to get our answer. So 1 plus 1 equals 2. 1 plus 1 equals this 2 right here on top. And then we just keep the 2 on the bottom. And then the answer is 2 over 2. And if you divide 2 by 2, you get 1. So the answer is 1. So the probability of getting a head or a tail when a coin is flipped is 1. And what this is actually saying is that this event right here, which is head or tail, always happens. Remember, an event with a probability of 1 always happens. That makes sense because when you flip a coin, you always get a head or a tail. Nothing else can happen. Each outcome has to be a head or a tail. So since head or tail always happens, then it means that head or tail has a probability of 1. Now let's go over another example. In this example, a card is drawn from a deck, and we want to know the probability of drawing a diamond or a heart. And these two events are mutually exclusive because when you draw a card from a deck, you can get a diamond or you can get a heart, but you can't get both of them together. You can't draw a card that's both a diamond and a heart. So since these two events are mutually exclusive, we can use the addition rule to find the probability of getting a diamond or a heart. To use the addition rule, we just have to add the probabilities of the two separate events. And the probability of a diamond is 13 over 52. because in a deck of cards, 13 out of 52 cards are diamonds. The probability of a heart is 13 over 52 because 13 out of 52 cards are hearts. And we can add these two fractions by just adding the two numerators. Because if they both have the same denominator of 52, which means we can just add these two numerators of 13. So 13 plus 13 is 26, and we just put the 26 over 52. And then if we could also divide 26 by 52, or I'm sorry, we could reduce the fraction to 1/2. And then after we reduce the fraction to 1/2, we could divide 1 by 2 and get a decimal answer of 0.5. So when you draw a card from a shuffle deck, the probability of a diamond or a heart is 0.5, meaning there's a 0.5 chance of this or this happening, one or the other. Now let's go over another example. In this example, we'll use the addition rule for the probability of 3 events. We'll use the addition rule to find the probability of getting a 1, a 2, or a 3 when a piece of dice is rolled. And the addition rule can be used here because these 3 events are mutually exclusive. When you roll a piece of dice, you can get a 1, you can get a 2, or you could get a 3 possibly, but you can't get any of these events together. None of these events can happen at the same time. So this is our addition rule. When you roll a piece of dice, the probability of 1, 2, or 3 happening is equal to the total of the probability of a 1, the probability of a 2, and the probability of a 3. We already found out earlier that each of these probabilities is 1/6 because every side has a probability of 1/6. So 1 out of 6 sides have a 1, so the probability of a 1 is 1/6. 1 out of 6 sides are a 2, so the probability of a 2 is 1/6. And 1 out of 6 sides are a 3, so the probability of a 3 is 1/6. So to get our answer, we just have to add these 3 fractions. Like I said earlier, if the fractions all have the same denominator, meaning they all have the same number on the bottom of the fraction, you just add the 3 numerators and then put the answer above the denominator. So 1 plus 1 plus 1 equals 3, and we just put the 3 over our denominator of 6, and the answer is 3/6. Or if we reduce, the answer is 1/2. Finally, we could change our answer to a decimal by dividing 1 by 2, and the answer is 0.5 as a decimal. I wanted to go through just a few more examples. Here's an example that says when you roll a piece of dice, what's the probability of rolling a 4 or higher? And if rolling a 4 or higher means what's the probability of rolling a 4, a 5, or a 6? Because those are the 3 numbers that are considered 4 or higher. So if I wanted to, I could have written this out as what's the probability of rolling a 4, 5, or a 6? It would mean the same thing. So the probability of rolling a 4 or higher is, like I said, the same thing as the probability of rolling a 4, a 5, or a 6. So to get the answer, you just add the probabilities of the 3 events. Each event has a probability of 1/6, so we just have to add these 3 probabilities. And just like before, they add up to 3/6, which reduces to 1/2, and 1 divided by 2 is 0.5. This one says, what's the probability of rolling a 2 or lower? And this is really just asking what's the probability of rolling a 1 or a 2, because 1 and 2 are the 2 outcomes that are 2 or lower. So the probability of rolling a 2 or lower or the probability of rolling a 1, 1 or 2, is equal to the total of the two separate probabilities. And we already know that each side has a probability of 1 over 6. So the probability of rolling a 1 is 1 over 6. And the probability of rolling a 2 is also 1 over 6. So the probability of rolling a 1 or a 2 is equal to the total of these two probabilities. 1 plus 1 is 2. So the answer is 2 over 6, which reduces to 1/3. And we could also divide the 1 by the 3 to get a decimal, and our answer would be 0.33. That was the last example that I wanted to cover for probability.